There are four gas laws that can be applied to respiratory function. Boyle's law, which is applied to inhalation and exhalation. Charles' law has to do with the inflation of lungs during inhalation. Dalton's law has to do with the composition of inspired air. And Henry's law has to do with factors that affect the diffusion of gases in external respiration. So the first three laws, Boyle's law, Charles' law, and Dalton's law, have more to do with ventilation, and Henry's law can be applied to understand external respiration. Boyle's law basically states that pressure is inversely proportional to volume. So when volume increases, pressure decreases. During inhalation, the volume in the thoracic cavity increases, and as a result, the pressure in the thoracic cavity goes down, and this allows the air to move in from the outside down the pressure gradient. During exhalation, the opposite happens. The volume inside the thoracic cavity goes down, the pressure goes up, and as a result, air is forced out of the thoracic cavity down its pressure gradient. Charles' law states that when pressure is kept constant, the volume of a gas increases along with the temperature. This means that on a hot day, the volume of a gas increases, the gas expands. On a cold day, the gas contracts, air contracts. So an easy way to remember Charles' law would be warm air expands. This is very useful to us when we're talking about inhalation. Now, here is the trachea, the bronchi and bronchioles entering the lungs. So as air comes in, it gets warmed up down the respiratory tract, and finally when it reaches the lungs, it expands so much that it inflates the lungs. This really helps with inhalation. Dalton's law has to do with the composition of air that we breathe in. Atmospheric air has a pressure of 760 millimeters of mercury. So this total pressure of atmospheric air is the sum of the partial pressures of all the gases within it. So those gases would be nitrogen. So there's the partial pressure of nitrogen, partial pressure of oxygen, partial pressure of water vapor, and partial pressure of carbon dioxide. Of these four gases, nitrogen has the highest partial pressure. 78% of the air that we breathe in is nitrogen, and only 21% is oxygen. Water and carbon dioxide make up 1% of the inspired air. Henry's law has to do with diffusion of gases at an air-water interface. Now, what's that? In the alveolus, there is water that lines the alveolar wall, but there's also air that actually reaches the alveolus, and diffusion must take place between an air and water. So in this particular situation, diffusion of the gas will depend upon not only the partial pressure of the gas, but it also depends upon the solubility of the gas in water. So for a gas to actually diffuse across the alveolar wall and capillary wall, you would need the gas to satisfy both of these rules, partial pressure of the gas and solubility of the gas in water. Clearly, nitrogen is the one with the highest partial pressure. Oxygen comes a distant second. However, it's oxygen that satisfies both rules, and so it is oxygen that ends up diffusing across the alveolar and capillary walls.